Right, so here we're looking at section 2.1 where we're talking about describing the location within a distribution. And so I've given you two sets of data. This data is, obviously it's made up, but we're looking at some test scores for two different statistics classes, one being Mr. Jenkins' class and the other being Ms. Brown's class. And so for these groups, we want to describe or create a display and then describe how the class performed overall. So I can create any kind of display that I would like for these two. I'm going to go ahead and do a stem plot for this first class. And so my lowest score in the first class is a 67, with the highest score being in the 90s. And so I'm going to do double stems here. Okay, and so these are test scores that I'm making a distribution for. And so I have 67. For the first 70 stem, it's going to be anything that's less than 75. So 73 or 72, 73 twice. I saw 74. Anything on the lower end of the 70s. All right. Then I have 77, 1, 2, 3 times. I have 78. Oh, there's a 75 also. Okay, so it's the 75, 3 77s, and a 78. And then 79 twice. Okay, the first 8 is going to be the lower 80s, so there's an 80, an 81, I have 82, I have 83, 1, 2, 3 times, and an 84. All right, then I have 85, 86, and 89. I have 90, 93, there should be two 90s, 93, and that should be everybody, so it's 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm missing someone. All right, so let's check again. All right, so I was missing the 93. So we could say the test scores for Mr. Jenkins' class are roughly symmetric with a mean of, and I'm going to figure that out now, and a standard deviation of blank, and I'm going to figure those out now. All right, so I used my calculator and calculated the mean of 80.4 and the standard deviation of 6.39. And I'm going to do something similar for Ms. Brown's class. I'm going to construct a display, and then I will compare her class to that of Mr. Jenkins. All right, so I'm going to go ahead and pause this and do the display and then work on the comparison. All right, so in comparison to Mr. Jenkins' class, we could say Ms. Brown's class has a test score distribution that is also roughly symmetric with a larger mean, which was 80.6, and more variation. Okay, and I know that more variation based on the standard deviation. Okay, so sometimes we want to be able to make comparisons between a student and the rest of their peers. And so there are two different things we can do in order to make a comparison between a student and the rest of the students in their class. And so the first thing we can do is we can calculate what's called a percentile. Okay, and a percentile is always the percentage of values below a given point. So in the case of Jackson's score, his percentile would be not 74. We need to figure out where 74 falls in terms of the rest of his peers. So at 74, there are 4 values ahead of him, so 4 out of 25. Is about is 16%, so this would be the 16th percentile. Okay, so that means he did better than 16% of the students who tested with him. Now, if we were to compare him to Ms. Brown's class, there are 30 students, and 7 out of the 30 performed below him, which would put me at 0.23 or the 23rd percentile. So he scored better than 23% of his peers in his class, in Ms. Brown's class. Now our second option is to use what we call a standardized score, or a z-score. Okay, and a z-score tells us how far above or below the mean a value falls in standard deviations. So the formula for a z-score is the value of x minus the mean over the standard deviation. So for Jackson's class, he scored a 74. The average was 80.4 with a standard deviation of 6.39. And this gives me a z-score of about -1. So that means that his score is 1 standard deviation below the mean or the average. Okay? And we could do the same thing for Ms. Brown's class if we wanted to. All right, and then finally we want to look at something we could use in order to display how Jackson did compared to his peers. And so for this, what we can use is a cumulative, relative, frequency graph. Okay, and so in order to do this, we're going to choose an interval for x's. We're going to find the frequency within that interval, and then we can do the cumulative frequency and then the cumulative relative frequency. Okay, and of course relative frequency means as it relates to everything else. And so I'm going to start by choosing the interval from 65 to 70, and then we're going to continue by 5s. And so essentially what I'm doing is recreating the information that's on my stem plot. Actually, I think in his class, in Mr. Jenkins' class, there was nothing above 93, so we're good there. All right. And so I'm going to take the information from my stem plot on the previous page in order to figure out the frequency. All right, and so the cumulative frequency is simply the sum of that row and whatever is before it. So in the first row, there's only a value of 1. In the next row, it would be 1 plus the 4 that follow, which is 5. Then we would add 7 again, add 3, and add 25. And so my cumulative relative frequency is each of these values divided by the total of 25. And we should always end with a total of 100%, right? So I'm going to go ahead and do these calculations. Okay, and so what I'm going to do is I'm going to take these cumulative relative frequencies and use them to display the information from this particular graph. And so what we're going to do is, or from this particular set of data. So what we're going to do is we're going to start by constructing two axes. Okay, along the x-axis, I'm going to put my intervals, which in this case are the test scores. And so I'm going to run from 65 up to 95, simply counting by 5s. And then what I'm putting over here on the y-axis is actually the percentiles. These cumulative relative frequencies are percentiles. They give us the percentage that falls below a given spot. And so I'm just going to count from 10 up to 100 by 20s. Okay, and so in order to display this, I'm going to start by looking at my first interval. And at the first interval, when we start, we have 0% before that particular point. So the percentile is 0%. From here, when I get to the end of the first interval, I've built up to 4%. So I'm at 4%, which is just above the axis in this case. Okay, so what I've done is I've graphed the 4% at the end of the first interval. Now my next interval ends at 20%, so I'm going to go down, and at 20%, I'm going to put my next point on the 75 and 20%, because when I get to 75, there's 20% below. Okay, my next interval runs up to 48, so I'm going to put a point on 48. From 48, we go to 76. From 76 to 88. And then finally all the way up to 100. Okay, and then when you connect these points, what you've constructed is your cumulative relative frequency graph, which is sometimes also called an ogive. Okay? And using the information in this graph, I can find the median. The median is the 50th percentile, so I could approximate the median, right? Median with just the 50th percentile. And then I can also approximate the quartiles. So this would be my first quartile at 25%, or the 25th percentile. And then at the 75th percentile, I could approximate the third quartile, and then use these two, right, in order to find the IQR. Okay?